Welcome to the last session of the day at Perfmon. I hope you've had a good day and seen some good sessions. I think it seems to be very full, so excellent so far. I've got your new title now, Alex, at E2E Virtualization Conference. So, just a quick introduction. My name is Jim Moyle, and I work for a company called Atlantis Computing. You can find me on Twitter at Jim Moyle, and I have a fairly unupdated blog at www.jimmoyle.com. So, here today to talk about IOPS, and specifically IOPS as it relates to Windows 7, and then how that relates to VDI. So, what exactly are IOPS? So IOPS stands for Input Output per Second, which is the amount of reads and writes of a certain block size per second that you get on your storage system. That's basically a benchmark of your storage system. It should be expressed in an actual number, just a count. You'll actually see it expressed quite often, especially when disk manufacturers are publishing their IOPS as throughput, as megabytes per second. That is incorrect. It just makes it sound more understandable for end users. The reason they can do that is because they know the block size. If you know the block size is completely consistent, then you can change IOPS into throughput. As we'll see though, that's not applicable in a Windows scenario. So, it wasn't that long ago when I knew that there was a thing called IOPS, and I knew that it had something to do with storage, but I didn't really care about it. Nobody really did. All we cared about was CPU and memory. And it's been the introduction of VDI which has made us all care about it, and made us all have to know about it. So, if we think of it back in the old pre-virtualization days, when you have one physical box, one OS, then we had a couple of spinning disks, maybe a bit of RAID 5, maybe some mirroring, but we knew that that was the performance of the physical disk. Yeah, we couldn't do very much about it. We couldn't go and, at the time, buy lots of SSDs. So, and the stuff wasn't on the SAN, it was all on local disks. So nobody really cared, because you had it, that was it, and you had to deal with it. And because Windows was designed to be able to cope with that amount of IOPS, then our performance was reasonable. But then we move into the virtualization days, and you have shared resources. So the three main things that you need for a performance OS is enough RAM, enough CPU, and enough storage performance. Because in a hypervisor the RAM and the CPU are local, so even though they're shared between multiple machines, it's still not that many. The storage layer is different, because storage layer is shared between multiple hypervisors. So instead of maybe a couple of hundred instances of VDI on a really big server, what you're getting is thousands of instances of VDI in your shared storage. So the problem is much more acute on storage than any of the other physical resources. One of the reasons why it's such a big problem is because A, it's not well understood, and B, it's really expensive to fix. So if you've implemented VDI, your proof of concept went well with 50 users, you've got a big SAN, then you upscale to 1,000, 5,000, 10,000 users, and you realize your performance is rubbish. And the reason is because most people have a tendency to buy less storage than they need. And this is a problem with both the VDI broker companies and with the storage vendors, because it's actually in both of their interests to undersize the VDI. Because if the storage vendors oversize the VDI, then they won't sell anything because the capex is too big. And the same applies to the broker vendors. So we know it's expensive to fix, and we know that it's one of the biggest bottlenecks in VDI. So we're going to talk a lot about Windows and what happens within Windows. And we're going to talk first off about which model you're going to take. Now, stateless subsystem is only a way of delivering your desktop. When it's actually running, it makes no difference because Windows will act the same way once it's been provisioned. The trouble is that what's happening is that people aren't, at least the large clients that I see, aren't going for the stateless model. So 8 out of the 9 really big financial institutions that I work with, only one is stateless, the rest are all persistent. The reason being is that it's taking too much engineering time to get to the stateless model before they go and can get VDI up and running. Whereas if you go persistent, they can use a lot of their old deployment tools, a lot of their existing IP, a lot of their existing skill set, and get the VDI deployment going very quickly, and then maybe optimize more in the post-process. So what happens when you do it that way around? Well, you have a generally unoptimized image. So you may have old agents kicking around in the image. You may have taken your just straight P2B, your existing golden image that you use for SCCM. So you could have stuff like inventory agents, backup agents, all kinds of rubbish in there that have been left over. And that has a big impact on the IOPS calculation. So, as we spoke before, Windows expects to have full access to the storage system. It has no concept of fair use. So basically what it will do is, if it needs more IOPS, it will try and take them. And it will try and burst as high as possible to try and get everything done. And in actual fact, the amount of performance gain that you can have by giving Windows more IOPS is quite stunning. So, who here has got a SSD in their laptop? Yeah. Who wants one? So, why does everybody want SSD in their laptop? It's because of the performance gain that you get from pure IOPS, from that increased IOPS. So a normal SSD will give you maybe 4,000 or 5,000 IOPS to your Windows machine. The other side holds true as well. So if you starve Windows of IOPS, your performance degrades. Queuing. So again, in the physical model, if you have your 200 IOPS SATA drive, then Windows is requesting whatever it can eat. You can't obviously deliver that, so the Windows OS introduces queuing. So it holds off the writes and reads until there is resources available to service them. If you've only got one queue, okay, fair enough. But ESX also has a queue, and SANs also have a queue. And what happens then is that you introduce latency. And when you're talking about performance, it isn't actually IOPS you want to measure. It's about latency. Because latency is the amount that the write or the read takes to come back to the OS, and that is the real measure of how performant your system is going to be. It has a direct relationship with IOPS, because if you increase the number of IOPS requested, then you increase the queue length throughout the system, and then you increase the latency. So, before we go on to this slide, it's why do we have problems with the spinning disks? Well, it's because of Moore's law. So as the CPU and memory have increased in capability, the storage subsystem has not increased in capability. The reason being is that although it's possible to make disk platters spin faster, the consequent increase in cost of cooling and power make them very, very, very expensive. So it's really a physical limit of that increase in power and cooling, which means that we can't make spinning platters better. So if we want to see exactly what is happening in that IOPS subsystem, we need a way to measure it. We need to be able to tell what's happening. Unfortunately, there is no way to measure what Windows is requesting. There is only a way to measure what is being delivered via the storage subsystem. So, if we look at our old friend Perfmon, discreet per second is read IOPS, writes per second is write IOPS. Current disk queue is the best you can get using Perfmon as an indication of the latency. You cannot get the latency as a measure of time, but the queue length is a reasonable indication of the latency. This transfers per second is just the total. You can also use ESX top to measure IOPS. So most of you are familiar with ESX top. If you go to the disk subsystem and you change, it especially helps to change the minimum timer for update to 2, which is the minimum for ESX top. Commands per second is your total IOPS. Reads and writes is fairly obvious. And your Q average at the end is your latency. So, given that we know all this about IOPS, we know that it's a problem, we're not quite sure how much. So I decided to test exactly what I said couldn't be measured, is what Windows will request. So where Windows will top out before it hits that CPU and memory limit. To do this, I used a basically software-based RAM disk in the back end and a single unoptimized Windows 7 VM running against that RAM disk. Fairly reasonable configuration, 2 GB RAM, 2 vCPU for the Windows 7, so not unusual. And then this graphic is from iometer, which will give you the maximum possible performance against a storage backend. I hate this program. I really do. It's so buggy. It was last developed sometime in 2006, and you can fake it as well. You can put configuration parameters into it, which means that you can get really odd results. So, as a tool, no, don't like it. But it is the only one around really that will give you a proper measure of the maximum performance of your infrastructure.
Jim?
Yeah.
Microsoft has a tool.
WinSat?
No, it's called Disk Bash. It's used internally at Microsoft. You can do if you contact support, they will give you Disk Bash.
Okay.
It has the same as it puts out the same values as iometer does, but it's just a command line tool and it's not fakeable. So Microsoft used this internally.
Okay. Anytime I have access to Microsoft internal tools will be good. So basically what we have is a single Windows 7 VM that's got 20 to 25,000 IOPS in the background. So let's face it, that should be enough to hit the next limit up, which will be the CPU or the memory. So what this should be able to do is, because we've removed as much as possible the effects of queuing in the background, and we've given Windows as many IOPS as it needs, we should actually see what Windows is trying to do. So exactly what's happening in the background. Because this will be the same if you've got lots of Windows 7 VMs against a SAN, because everything is shared. So Windows will try and burst as much as it can. So this is its recommendations for IOPS for Windows 7 VMs. It's on the high side of a lot of other different recommendations I've seen from storage vendors. VMware don't